Hey, this is Mr. James. In this video, we're going to be talking about the angles of different kinds of triangles. As you're watching the video, please make sure that you can pause, try practice problems, and rewind if you need to. Be sure to take notes and bring them in for the video check next class. And so let's take a look at this note sheet here, angles and sides of triangles. So before we start at the top, we're actually going to scroll down a little bit and take a look at the different kinds of triangles before we talk about their angles. So there are two ways to talk about triangles. We can either talk about them based on their side length, okay, or we can talk about them based on angles. So first, let's talk about triangles based on side length, how long the sides are. Now there are three kinds: scalene, isosceles, and equilateral. Remember, a scalene triangle is a triangle with no congruent sides. None of the sides are the same length. So no congruent sides. Okay. So if you're going to make up some numbers, maybe this is 3 centimeters, this is 4 centimeters, and this is 5 centimeters. None of them are the same size. On the other hand, an isosceles triangle has two congruent sides. So maybe this side and this side are congruent. So it's got two congruent sides. So if you'd make up side lengths for those, maybe they would be, I don't know, 5 centimeters, 5 centimeters, and I don't know, 8 centimeters. Something like that. On the other hand, we also have an equilateral triangle, and you might know that an equilateral triangle has all three congruent sides. So all congruent sides. All congruent sides. Now those are based on side length: scalene, isosceles, and equilateral. On the other hand, we could talk about triangles based on what their angles look like. Okay, so an acute angle is, remember, a triangle with all acute angles. All three angles are acute. Okay, so for example, it could have angles that were, I don't know, 60, 50, and 70 degrees, something like that. They're all acute. A right triangle, remember, is a triangle with one right angle. One right, remember, 90 degrees angle. So, for example, this could be a 90-degree angle. We could have, I don't know, a 90, a 30-degree angle, and a 60-degree angle. And then the last kind, remember, is obtuse. Obtuse, so that's got one obtuse angle. One obtuse angle. And you could never have an angle with more than one obtuse angle, because then the sum of all the interior angles would add to more than 180 degrees. So maybe your obtuse angle could have, I don't know, 120-degree angle, and then 20 degrees and 40 degrees, something like that. Okay, 120, 20, and 40. And like I said, an obtuse triangle can't have more than one obtuse angle, because think about it. If I had more than one obtuse angle, let's see, it's something like 120, another obtuse angle like 120. I'm already over 180 degrees. So 120 and 120 is 240. And I can't have a triangle with more than 180 degrees, so I definitely can't have more than that one obtuse angle. So we've learned about scalene, isosceles, equilateral triangles based on side length. We've learned about acute, right, and obtuse based on angles. And those are kind of a review from maybe middle school or even elementary school. But let's return back to the top of the page here, because there's something special that happens between the sides and the angles of a triangle. To see this relationship clearly between the angles and the sides, do this for me. Grab a scrap piece of paper or a napkin or a whiteboard, some sand, draw on the sand, I don't care, whatever you want to do. And draw me a triangle that has one very long side, one kind of medium length side, and one shorter side. Okay? And we'll call the vertices A, B, and C like this. Now, here's our longest side. Here's our medium side. Here's our short side. Okay, let's actually write that down in our notes. So our shortest side was CB. Our medium length side was AB. And our longest side was CA. All right, back to the drawing. And now we look at the angles, and we can say, okay, well, my smallest angle is angle A. It's small. The medium-sized angle is C. And the largest angle is B. Let's write those down. All right, write the angle of measures from smallest to largest. My smallest again was angle A, and the medium one was angle C, and the largest one was angle B. Hey, I'm starting to see a pattern here. Let's go back to the diagram. So looking at my diagram, I'm seeing that the longest side and the largest angle are directly across from each other. This is my longest side. This is my largest angle. I'm also seeing that the shortest side is across from the smallest angle. And in fact, the medium length side is across from the medium length angle. Huh. I think I'm ready to write a conjecture about what I'm seeing. I know that the longest side is across from the largest angle, and the smallest, or let's say shortest, side is across from the smallest angle, and of course the medium side's across the medium angle in any triangle. And in fact, that conjecture is a theorem. That is always true. If you've got yourself three different colors, you can actually draw a little picture to illustrate that, right? Here's our longest side and our biggest angle. Here's our shortest side and our smallest angle. And here's our medium length side and our medium length angle. Okay? And so this holds for any triangle. So knowing that, pause the video here and try and identify the smallest and largest sides of those two triangles and the shortest and longest angles, shortest and longest sides of those two. Pause the video here and try to answer those four questions. Alright, hopefully you've tried those. Let's take a look at the answers. Well, since the shortest side is HK, my smallest angle will be angle J. Since the longest side is HJ, across from it is my largest angle, which will be angle K. For the next one, my smallest side looks like to be AB, so my smallest angle is going to be angle C. And my largest side seems to be BC, so the largest angle will be angle A. For the next one, we're talking about sides and angles kind of backwards over here. So the smallest angle is angle R, so the longest side will be NM. So N side NM. On the other, conversely, the longest side here, well, here's my biggest angle. So the longest side's across from that. It's going to be NR. NR is my longest side across from the biggest angle. This last one's a little different. My longest side is pretty easy to see. Here's my biggest angle, and so across from that is my biggest side, my longest side, PQ. But for the shortest side, it's a little bit confusing because there's a tie here. Both this angle P and this angle Q are both the same measure, which means actually that the sides across from those will tie for the same length. So PO and OQ tie for the shortest length side of that triangle. That's kind of interesting how things tie like that. And maybe we could use this theorem that we just learned and apply it to the different kinds of triangles. Let's see how we can do that. Take a look at these three triangles right here. The first one has three different side lengths, and so we would call it scalene. The second one has two of the same side lengths, so we would call it isosceles. And the third triangle has three congruent sides, three congruent side lengths, so we would call it equilateral. So based on what we know before, I want you to try and answer these questions. Now, they are not on your note sheet, so maybe use a separate sheet of paper, or just think about them in your head for a second. Pause the video and see if you can figure out what the smallest and largest angles of each of those triangles are going to be. And you'll be surprised with the results you see for 3, 4, 5, and 6. Pause the video now. So to make things easier to see, I'm going to use the color purple to mark all of the longer or larger angles. I'm going to use the color green to mark all the smallest angles. So we're looking at this first one, the scalene triangle. Well, we know that the smallest side is 19 centimeters, so the smallest angle is going to be across from it, angle E. Whereas the longest side is 21 centimeters, so the largest angle will be angle C, right across from it. Now something funny happens with 3, 4, 5, and 6. With the isosceles triangle, we know that the smallest side is the 7 centimeters, so the smallest angle is going to be angle H. But the longest sides are a tie, and so the longest or the largest angles will also be a tie. Okay? And actually this happens every time we have an isosceles triangle. In an isosceles triangle, the angles that are opposite the two congruent sides will also be congruent themselves. In an equilateral triangle, well, every side is the smallest side because they're all congruent. And as a result, every angle will be the smallest angle. Okay? They're all congruent. So in an isosceles triangle, we have two congruent angles, and in an equilateral triangle, we have all three congruent angles. Let's write this down on our note sheet. So we're back on our notes, and we've learned before that a scalene has no congruent sides, but now we can add something to that. From what we've learned, a scalene triangle also has no congruent angles. An isosceles triangle has two congruent sides, but we've also learned that it's got two congruent angles, the angles that are across from the congruent sides. We call these angles base angles. Okay, so that angle there, those are called base angles. And we say that base angles, so the two base angles, are congruent. And in an equilateral triangle, we've learned that since all three sides are congruent, all three angles are congruent. So all angles are congruent. And we have a name for that. That's equiangular. When all the angles are congruent, it's called an equiangular triangle. And I guess we can also add a few things for acute right and obtuse angles. We've learned that the longest side is across from the longest angle. So for a right triangle, the longest side is always across from that right angle. That's the longest side. And for obtuse angle, same thing. The longest side is always across from that obtuse angle, because that'll be the biggest angle. Longest side right there. Flip to the other side of your notes where it says types of triangles. We're going to do these 6 examples right here. Pause the video and try and classify the first 3 as either scalene, isosceles, or equilateral. Then try to classify the next 3 as either acute, right, or obtuse. Pause the video now. Alright, so let's take a look. A triangle with sides 10 centimeters, 25 centimeters, and 10 centimeters. Well, it's got 2 congruent sides. That means it's isosceles. A triangle with sides 5 centimeters, 5 centimeters, and 5 centimeters. Well, we know that's going to be equilateral. Now this one, a triangle with angles 30, 60, and 90. Well, these words have nothing to do with angles. But we just learned that if the angles are all different, then the sides will also be all different. And so this is scalene. So even though we started with angles, we can figure out something about the sides based on what we've just learned. All right, let's take a look at 4, 5, and 6. So for 4, looks like we've got an acute angle, but we've got one obtuse angle. So this is a obtuse triangle. Again, these all have to do with angles. A triangle with angles 30, 60, and 90. Well, we had that before when we called scalene, but now we're classifying by the angles, and this is going to be a right triangle, because it's 90 degrees there. And the last one, triangle with sides 5, 5, and 5. Well, this doesn't tell us anything about the angles, except, hey, wait, a 5, 5, and 5, that's an equilateral triangle, and equilateral triangles also equiangular. We know there's 180 degrees in all of those angles, so 180 divided by 3, that means each of these are 60 degrees, and that is an acute triangle. So in this video we've learned how to classify triangles based on sides and angles. We've also learned the relationship between different sides and different angles of triangles. This next part is not in our notes, and is a preview of what we're doing next class. What I'd like you to do is pause the video here and try and solve for x in each of these 4 triangles. Now remember what we've talked about before about isosceles and equilateral. See if you can do it. Pause the video here. Alright, let's walk through them. Again, this is a preview of what we'll be doing next class, so this is not in your notes. The important thing for all 4 of these is to remember that the angles of a triangle add to 180 degrees. That's the key for all of these. This first one is something that we've seen before. We've got a 90-degree angle and a 30-degree angle, and since we don't know this angle, but we do know that all the angles add to 180, we can do 180 minus 30 minus 90, and that gives us 60 degrees. So x in this first one is a 60-degree angle. The second one, well, we don't have what this other angle is here, so we can't subtract from 180. But we can figure it out. Since this is an isosceles triangle, okay, shown by these 2 congruent sides, we know that the opposite angles, called the base angles, are congruent. So since this is 70 over here, this will also be 70 degrees. And now we know this is 70 degrees. This is 70 degrees. We can figure this one out. 180 minus 70 minus 70. Let's see. That will give us 40 degrees. So x is 40 degrees. Over here, it's much the opposite. We know that this is 80 degrees, and we don't know what this one is. Since this side and this side are congruent, we know that the opposite angles, the base angles, will both be congruent. So if this is x, this is also x. So if the top part is 80, let's see, 180 minus 80 is 100. It means we've got 100 degrees to split between these 2 base angles. And since we know they're congruent, they'll all be exactly half of that 100, which is 50. So x in this case is 50 degrees. Lastly, we've got an equilateral triangle. We know that because all of the sides are congruent. And we don't have any of the angles marked, but that's okay. Since all the sides are congruent, we know that all the angles will also be congruent. So we can take that whole 180, divide it 3 ways, and know that each angle in an equilateral triangle is always 60 degrees. So x 60 in this case. Hopefully you got these last 4. If you didn't, it's okay. We're going to talk about them more next class. Remember to bring your notes, be ready for the video check, and good luck.